And then I gotta.
I don't know. I'm not sure about
This morning?
because I need
Wait, what?
This
What
one.
talk?
I usually go
For what? Cross country or something?
So I heard y'all lost very badly in kickball.
Oh yeah. They got stomped.
They're lying.
That's a difference. 20 to 4.
Yeah.
That's what I'm about.
Okay, but there was 8 people on their team, and there was only 7 on ours.
Wow.
We had a
one
cripple.
person.
What?
We had Toller.
Kid.
Toller could not do anything.
Oh my gosh, he pitched.
That's doing a whole
And
lot.
still
Abby's pretty much crippled on our team because she couldn't catch a ball. So yeah, we have a crippled person too.
What?
She probably shouldn't be able to do it. She can't catch a ball.
Yeah, I moved her to pitching. So
Alright, this new fancy thing's supposed to be working, but it worked for about 5 minutes first period, and that was all. So I'm gonna attempt with y'all again. Even if it does work, I'm not as good with it yet as I was the other one, but
that's new.
yeah. Alright, on number 1, we've got negative 32 to the 3/5 power. So if we're looking at simplifying that, what we need to remember about that 3/5 power is that's power over roots. Okay, this is one that you could just type into your calculator. Okay, I did it without, so I did the 5th root of negative 32 cubed. The 5th root of negative 32 is negative 2. Because 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. So then I had negative 2 to the 3rd, which was negative 8. But that is one that you could just type into your calculator.
Does the powder ever went off at the school?
Yeah.
Yes.
and that was
A lot.
That's your mom.
We
got
Bro, I remember that. That was
because if you get
eighth
power
grade.
back
Yeah. And we all got to go home.
was it that answer 80 or so?
Negative 8.
That's pop.
Oh, I had that.
Alright, this one, shall be quiet. This one you cannot just type into your calculator because it gets you a decimal answer on anything, and then if it does not say round, you don't get to just round it to some decimal answer. You've got to leave it in radical form. Our deal with this is we're not allowed to just subtract because square root of 72 and square root of 2 are not the same. But square root of 72 will break down. That's the same as 2 times the square root of 36 times 2.
You did not write it.
Yes, I did. Then what's the square root of 36? That's 6, so we're bringing a 6 out, but there's already a 2 out there. So 6 times 2 makes that 12. So we got 12 square roots of 2 minus 3 square roots of 2, which is 9 square roots of 2. This is like when you watch those foreign films where the words are behind the mouths.
I hate those.
That's what this is like writing. Yeah, it's
Is that an
iPad.
iPad or what?
All right, 3. Pretty simple one on number 3. And you know, if you can just test them in your calculator and see if it gets you a whole number. I got you, Gabe. There you go. Maybe. Yeah. You can just test them in your calculator and see if it gets you a whole number. 3's one that should. We good? All right, we got the 5th root of 1,215 divided by the 5th root of 5. Now, I know on that denominator, the 5th root of 5, that's not a perfect 5th, but what I did was I looked at 1,215. This is how you would do it without a calculator, and I knew that that was the same as, I didn't show my work on that. I think it's 125 times 5. Somebody check that for me. See what 125 times 5 is. No, that's not even right. That's not even right.
Can you just type that in your calculator?
I've said that 4 times. 243, that's what I was looking for. So I got the 5th root of 243 times 5. And then the 5th root of 243, that's 3. 3 times 3 is 9 times 3 is 27 times 3 is 81 times 3 is 243. So I have 3 5th roots of 5 over the fifth root of 5. And then those fifth roots of 5 canceled out, and all you got left is a 3.
3 on 3.
Wait, how did you get from 243 times 5 to 5?
Top of your
The
head.
fifth root of 243 was 3. So I brought the 3 out. This brings a 3 out and leaves a 5 in. So it was like that. Good. All right, on 4, got the cube root, -8, x cubed, y to the 5th, z to the 7th. So we're looking at just simplifying here. Cube root of -8, you can have a negative when it's an odd root. Cube root of 8's 2, so the cube root of -8 would be -2. So I know I'm going to have a -2 that comes out from that. Alright, then next, moving left to right, look at your x cubed. The cube root of x cubed, the cube root and the cube just cancel out, so you've got an x from that. Alright, now on the y to the 5th. Rewrite that y to the 5th as a perfect cube. It would be y squared times y cubed. Cube root of y cubed would cancel out, so I would bring that out, but then that y squared is going to have to stay in the house. Okay, then we'll do the same with the z's. Z to the 7th, that would be z cubed. Z cubed, that's 6. And then I would need one more z to make 7, because that's 3, 6, 7. So the cube root of z cubed is z, but you have 1, 2 of those. So you bring a z squared out, and then that z would have to stay in the house. So everything that's outside the house in the wiffle ball game, I've written over here at the right that I just underlined. The stuff that's circled is still inside the house. So when you write your final answer, you're going to have -2xyz squared times the cube root of y squared z. And that'd be your final answer on number 4. Okay, 5 will work pretty good in your calculator. Doesn't have any variables. That'd always be a good thing to try when you don't have any variables. It's easy to do with power over roots. I've got 27 to the 2/3 power. Power over root means I'm doing the cube root of 27 squared. That's easy because we've used the cube root of 27 a lot. 3 times 3 times 3 gets 27, so that's 3 squared, which would be 9. Do I need a plus minus on this one?
No, it's not even.
Very good, Chloe. That root's odd, so that's all you got.
What the?
Alright, on 6. That was probably the one I had the most questions about all day long. People had forgotten about how to cancel out that radical on bottom. We got 2 over 1 minus the square root of 2. The dilemma, the reason it's a little bit more difficult to cancel out is because it's part of a binomial. So what you do when it's part of a binomial is you multiply top and bottom by its conjugate. Conjugate means same stuff with different signs. So you would multiply top and bottom by 1 plus the square root of 2. Okay, on the top, that's just an easy distribute. That gets you 2. 2 times 1 is 2 plus 2 square roots of 2. We just distributed that 2 to both of those. Now on the bottom, you got to FOIL that. So I'll do it over here on my first. That 1 times 1 is 1. You're going to see that the square roots cancel out. On the outer, that's a plus square root of 2. And on the inner, that's a minus square root of 2. So those cancel. And then on my last, I got minus the square root of 4. The square root of 4 is 2, so minus 2, which you know is negative 1. So over here in my numerator, I got all of that over negative 1. You can leave your answer like that. Okay, I'm fine with that. This is not a multiple choice test, so you don't have to even mess with different options. But some of you might want to just divide them all by negative 1, so you might write your answer like that. These are the same, so either one of those answers would be good.
Why are your tests not multiple choice?
Because they're not. Alright, on 7 it says the transformation of f is represented by the g, so write a rule for g. Writing a rule just means the equation, so it's going to be g of x equals something. Okay, what you've got to look at there on number 7, they give you, started with the parent function, f of x is equal to x, and we graphed that real good in class when we did that. We said the parent function of a square root would look like that. It would have a point at the origin. It would have a point at 1, 1, right? So the one they gave me, they've scooted it way over here. And that point, it says, is at negative 3, 0. So what used to be at 0, 0, they've scooted left 3. This one here, it's at 1, 2. So what used to be at 1, 1, it's now over there at 1, 2. So if we were at 0, 0, and we moved it left 3, we're trying to write a rule for this. Scooting left and right goes in with the x, right? Left and right's opposite way. So the opposite of going left 3 would be to add 3. So all of that's in the radical, because when it's left and right, it goes in with the x. Okay, number 8 was a little bit, wasn't as obvious as that one, because it wasn't just a scoot. The scoots are, y'all do pretty good at the scoots. Those are always pretty easy. 8, you're looking at shrinking or stretching, so you had to figure that out. We ready? Okay, it started off with f of x is the cube root of x. And if we looked at that, if I think about an input-output table, if the cube root of 1 would be 1, right? Well, look at that graph they gave you. They've got over 1 and up 4 as a point. So what was over 1 up 1, they've stretched it to over 1 up 4. So they've multiplied that by 4 to get it up there, because I know it didn't scoot is the reason, because it's in the origin, right? So it didn't scoot up or down any. So just multiplied it by 4. So I'm going to say g of x is equal to 4 times the cube root of x. Alright, 9, it's just scooted. See how the difference on 9? Because all your parent functions on radicals and roots all go through the origin. But on 9, it's not 0, 0, it's 0, 1. Can you see that when you're looking at it? So they've scooted it up 1. So on 9, I'm going to take this f of x that they gave me, and I just got to scoot it up 1. Up goes outside, stuck on the end.
Can you go back?
Alright, on 10, bless you. 10 was a little bit harder for me because it has two things happening to it. You ought to be able to look at your picture on 10 and see it's scooted down, right? Because it moved down to 0, negative 2 instead of 0, 0. So you know it's going to have a minus 2. But then it's also got a stretch on it, because that point that's at 1, 1, when it got scooted, it would have originally been at 1, 3. Okay, what you're looking at there, I know you don't, your parent function's like that, which has that point. This is your parent function of a square root, which has 0, 0, 1, 1, 4, 2. I wrote 1, 2 instead of 1, 1. 1, 1. Okay, but on the graph they gave you, that one on the graph they gave you the ordered pair 0, -2, 1, 1, and 1. No, they didn't give you 1, 1. They didn't give you 1, 3. Okay, so if you're looking at that, to get from 0, -2, they drug it down 2. We already said that. We already got that. So we're square root of x minus 2 to start with. But if I plug this other point in, if I plug a 1 in, square root of 1 is 1. 1 minus 2 is -1. But this says it's still supposed to be 1, not -1. So I would have to multiply it by something to make that work out. Look at what a 3 would do. And I just did that by trial and error. I'm saving you a little bit of time on that. This would be if you plugged a 1 in, square root of 1 is 1. 3 times 1 minus 2, yes, that equals 1. So your g of x, I started to write f of x, g of x is equal to 3 square roots of x minus 2. Alright, 11's a pretty easy one. You're just plugging in numbers and filling that table in. So that ought to be a quick time saver for you on 11. Give you a second to get caught up. I got it? Alright. Says, gives you the equation t equals 2.31 times L to the 1/2 power. And then your L's are what you're given in that table. 60 feet, 40 feet, 100 feet, 300 feet. So like for the first one, you just got to figure out 2.31 times 60 to the 1/2 power. So you're just plugging those in your calculator. It tells you to round to the nearest tenth. So make sure you follow your rounding directions. I got 17.9 on that one. Then the second blank, I plugged a 40 in instead of a 60. I got 14.6. The third blank, I plugged 100 in. I got 23.1. And the last blank, when I plugged a 300 in, I got 40.0. I normally don't write 0.0 because that doesn't change it, but I wanted to make sure I followed the directions and rounded to the 10th.
Do you hear that?
Yeah.
Yeah.
12 had a lot of answers on it.
Oh, wait.
Holy.
I missed something.
11, we just filled that chart in. Those are all the answers.
For number 11.
Yeah.
Oh, okay. Okay, when you said 12 has water, I thought you were talking about this.
Oh, my bad. Yeah. Alright, on 12. Says let f of x equal -2x to the 2/5. G of x equals -x to the 2/5. Wants us to add them. That's your first blank. Subtract them. That's your second blank. State the domain of each. That's blank 3 and 4. And then evaluate them for 243. So that's blank 5 and 6. So this problem has 6 points on it. Okay, first off, when I add them, if I've got -2x to the 2/5, and I'm adding that to -x to the 2/5, those are like terms because they both got an x and they both got a 2/5 power. So -2 of them plus -1 of them gets you -3 of them. So that would be your first answer.
Yep.
Okay, the second one says subtract them. So if I had -2x to the 2/5 minus -x to the 2/5, subtracting on that, -2 minus -1, That's -1. So that's your second answer. Okay, the third and fourth are what a lot of people asked me about last week. State the domain of each. Domain has to do with left and right. So you're talking about if you graphed these, would they ever stop going left and right? Since this, if you think of power over roots, you're taking the fifth root, which is an odd root. Can you have a negative when it's an odd root? Yes, Jody's correct. Can you have a positive when it's an odd root? Yes, Jody's correct. So there's no limitations on that. So for my domain, it's all real numbers on both of them. So I had two answers there, number 4 and 5, where I wrote all real numbers. When it would be limited is if your root was even. Then it would have to be bigger than, it had to be 0 or bigger. It had to be a positive because you can't have a negative root of an even unless you're imaginary. Okay, the last two answers say solve both of those for 243. So you're going back to both of these first two answers right there where I just underlined, and you're plugging 243 in for both of those x's. Okay, on the first one, when I plugged 243 in, up there with the -3 times 243 to the 2/5 power, I got -27. Y'all can check that on your calculator. And then on the last one, -243 to the 2/5 power got me -9. We are ready for the back page. Similar type of problem on 13 to what you just did, but instead of adding and subtracting, you're multiplying and dividing. Okay? Alright, so it says f of x is 2/3, x to the 3/2, g of x is -4x, multiply them. So if I had, my first answer, if I had 2/3 x to the 3/2, and I'm multiplying that by -4x, that gets me 2/3 times -4 is -8/3. And then I add 3/2 and 1 on my exponent, and that's 5/2. So there's my first answer on number 13. My second one says to divide them. So I got 2/3 x to the 3/2 divided by -4x. 2/3 divided by -4 is -1/6. Then when you're dividing with exponents, you subtract. So 3/2 minus 1 is 1/2. So there's my second answer on number 13. This is what I was just talking to Jody about on the domain. That's the next two questions. This one, my power over roots, I got a 2 on the bottom, so I'm taking the square root. You can't have a negative when you're doing square root. So for your domain, your third and fourth blanks has to be greater than or equal to 0 on both of them. And then your last two blanks, the fifth and sixth blanks, you're plugging a 4 in to both of your answers on the first two blanks. When I plugged a 4 into the -8/3 one, I got an ugly fraction. I left it as improper. -256/3. And when I plugged a 4 into the -1/6 one, I got -1/3. And that's just you having to push the buttons and check it and make sure you can get it. Alright, 14, you got two answers on it, and there could actually be lots of different answers. I just left mine generic. Ask you to write two functions whose graphs are translations of y equals square root of x. The first one, the domain has to be bigger than -3. So square root of x, square root, like we just said, means you can't have a negative underneath the radical. So if I wanted my domain to have to be bigger than -3, I'm going to say y can be the square root of x plus 3. Okay, because if I put a negative 3 in for the x, that's 0. Square root of 0 is 0, so that would work. So I could actually plug in anything as long as it didn't get me a negative underneath there. Why was the second one says should have a range of less than or equal to 3. So range less than or equal to 3, that means range is the y, so that means I'm moving up 3. So I say y is the square root of x, and my up and down gets stuck on the end. Alright, 15. The equation D equals 1.35 h to the 1/2 represents distance in feet you can see onto the horizon, where h is the height of your eyes above ground level. Determine how tall a person is if they can see 2.75 miles out into the horizon round to the nearest hundred. So all you're doing is plugging 2.71 in for the 2.75, into the distance, because that's how far this person can see. So 2.75 is equal to 1.35 h to the 1/2. Okay, since that whole 1.35 is to the 1/2, I would undo that first. How do you undo a 1/2 power? Good, Stephen. So you're going to square everything. Very good, Stephen. 2.75 squared, that got me 7.5625. Then the last thing you would have to do, your h would be multiplied by 1.35. So you're just going to divide by 1.35. It says round to the nearest hundredth. So when I did that, I got 5.60. It's almost there. There it is. And that's how tall a person is, so I'm going to put feet on there. I don't like 5.6 because people think that's 5'6". That's not true. That's not 5 feet 6 inches. That's 5.6. That's different. Y'all don't care probably. No, I think it would actually be 6/10. Would it be 4 inches?
Yeah.
I think that's right. All right, 16 says solve those two, and the only difference, one of them's got a less than and equal sign, one of them's equal. Describe the similarities and differences between solving them. So what I did is I just showed my work of me solving them. So that's what I would want you to do. So let's do the first one. I've got the less than sign, 6 square roots of x minus 2 plus 4 is less than equal to 28. Alright, so we're going to start getting rid of extra junk. So first thing I did was subtracted the 4. So I have 6 square roots of x minus 2 is less than or equal to 24. Then I divided by 6. So I have the square root of x minus 2 is less than or equal to 4. Then I got rid of squared by square and everything. So I had, I took this, undid the squared and square root. Then your last, I erased that. Why did it not go off? It went off of mine. That over there on the right, x minus 2 is less than or equal to 16, should not be in a square root, but it's not on mine. So I don't know why it's on yours. This came off of mine, but not off of yours.
That's good.
Okay, so then your last step, the x has got 2 being subtracted, so you're going to add 2. So you'd have x is less than or equal to 18. Now when you write that, go back and look at the original equation we got up there at the top. If I plugged a 2, because it says x can be anything smaller than 18, right? If I plugged a 2 in up here in the original problem, that's okay. 2 minus 2 is 0. What if I plugged a 1 in? Right, 1 minus 2 is a negative 1, and now we're talking imaginary, so that's not possible. So while x has to be less than or equal to negative 18, it also can't go below 2, can it? So when I write my answer for this first problem, first part of number 16, it's got to be between 2 and 18. So I would write it like that. Now you're only halfway done with number 16. That was the less than or equal to sign. Now we got to do the equal sign. Good news is you do it the exact same way, but you still got to show your work because that's what the problem asks us for. Okay, everybody got that part ready? Okay. Alright, same exact problem, except now it's got an equal sign. So we got 6 square roots of x minus 2 plus 4 is equal to 28. Okay, same steps on this. Subtract the 4 both sides. That'll get you 6 square roots. Or I can't say 4 and write 6. It doesn't work. Okay, something's the erase on here. I just erased 6 and wrote 4, and it didn't erase.
So.
Have to remember that this doesn't erase up there; it only erases here. All right, I got me 6 square roots of x minus 2 is equal to 24. Then we divide it by 6. So that got me the square root of x minus 2 is equal to 4. These are all the same steps we had on the other one. I wrote mine like in 2 columns in that big space they had left for me there. And it'll catch up, hopefully. And then we undid that square root by squaring. Okay, we're rocking now. So we have x minus 2 is 16. And then added 2, so we add x is 18. And now you're finally done with 16. So the difference in adding that less than sign was you were limited. It had to be between 2 things. Equal sign, bam, it's 18, nothing else. All right, we got an inverse question on the last one. All right, total number of months it takes to produce tennis rackets is in thousands, and that's important, is given by that formula. Months is equal to p cubed. That's the tennis rackets produced divided by 90. Part A, find the inverse. Well, we find the inverse. First thing we do is switch the variables. So P equals m cubed divided by 90. And then we solve for our new one. Usually we say solve for y, but in this case it's m that you're solving for. It's being divided by 90, so we'd multiply by 90. So we got 90p is equal to m cubed. Now it's being cubed, so we undo the cube by cube rooting. So m would equal the cube root of 90p. So there's your first blank on find the inverse. Part B says how many tennis rackets will be produced in 20 months. So when you do this 20, you're actually plugging it into your new formula there. So you're going to have just 90 times 20. Checking and making sure real quick. Yeah. So we've got for our second blank, part B, we would have 90 times 20, and then we would cube root that. So that's the cube root of 1800, which ends up on my calculator when I type that in, the cube root of 1800 ends up as 12.164. If you put that, that's going to be wrong because the question says tennis rackets in thousands. So 12.164 in thousands would be, change that to a comma, 12,000, I'm just going to scoot it up, 164 tennis rackets. That's another thing that's different on this that I don't like. It's the old one that was tore up, you could use it as the mouse and do all that stuff. This one you can't, it only writes.
Why didn't y'all just get a new?
They quit making them. That's how old that thing was. This is supposed to be the new and improved stuff.
But it's new and old, like unimproved.
Yeah.
Is that a 6 and a 4?
Yes.